Alright, and here is the video for 6b. Again, there's not a whole lot to calculate in this one, a lot of terminology, but there's a few things that may be unfamiliar, so we're going to go through a couple of examples. But 6b is on measuring variation. 6a was on basically measures of center and shapes, and we talked a little bit about looking at the shape of the distribution, whether it was, if it was low variation, a shape like that, medium variation, there should be peaks on those, or if it had like high variation. But here we're going to have a little bit more specific way to quantify variation. So why does variation matter? Well, consider wait times for 11 customers at two banks. Very creative names, Big Bank and Best Bank. Okay, so Big Bank has 3 lines and Best Bank has only 1 line when people go to the bank. And these numbers are the average, or these are lists of 11 wait times, how long 11 customers had to wait at the 2 different banks. Okay, now if you look, Big Bank has a couple short wait times, several about in the middle, and then a couple longish wait times, some 8, 9, 11 minutes. Best Bank have all of them about the same. They're all between about 6.5 and about 8 minutes long. But which bank is likely to have unhappy customers? Well, look at this. If you look at how the data varies, okay, this data is very, very spread out. So if you show up to Big Bank, look at the heights of the 7, 8, 9, 10 minute wait times, right? You're very likely to get one of these wait times. Maybe you'll get a really long wait time, maybe you'll get a really short wait time, but this is very spread out data. However, if you go to Best Bank, you're waiting either 7 or 8 minutes. This is not spread out at all. Okay, so this is pretty much what you can expect if you go to Best Bank. You know that you're waiting 7 or 8 minutes. There's no surprises. But if you go to Big Bank, if you just pop in, you're about equally likely to get any of these. Okay, these are a little bit higher, but you may get 11 or 8 or 9, so you can have some surprise long wait time. So customers at the Big Bank are more likely to be unhappy because of some surprise wait times. Okay, so how can we measure variation? Well, the first measure is just by looking at the range of the data. And the range, you just take the maximum value, the highest value, and subtract off the lowest value, this minimum value. So that's the range. And it can be useful. Not always, but it's kind of a rough measure of variation. Let's look at this example. Here we have 2 quizzes that non-students took. Which one has the biggest range is the first thing we're going to answer, and which has the biggest variation. So the next slide is going to have the calculations, which are pretty easy, but let's just look at these numbers. Quiz 1, one person scored a 1, but everybody else got a 10. Okay? And on quiz 2, we had a score of 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now let's think about this. The range for quiz 1 is the highest value minus the lowest value, so it's a 9. So a 9 would be the range. The range for quiz 2 is the highest value minus the lowest value, 10 minus 2, which is 8. Now, the range for quiz 1 is 9, which is greater than the range for quiz 2, which was only 8. But even though it has the bigger range, we wouldn't necessarily say that quiz 1 has more variation, because quiz 1 doesn't have much variation at all because everybody got a 10, except for that one outlier. Okay, everybody got a 10, so there's not much difference in the numbers. There's not much variation. But in quiz 2, there was a lot of variation. The quizzes were spread out between the 2, 3, 4, 5, 6, 7, 8, 9, and 10. So even though quiz 1 has a higher range, quiz 2 actually has more variation. So a little bit better way to measure variation is with what's called a box plot. And to do a box plot, you first of all have to talk about quartiles. Now, quartiles divide your data up into 4 pieces. And this is the general idea. We have the lower quartile, or Q1, the middle quartile, or Q2, the upper quartile, or Q3, and then we have the minimum over here and the maximum over here. So all the rest of your data is going to fall into one of these four places, either here, 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 or here. So it divides your data up into four different pieces, the quartiles do. The lower quartile is what divides the lower fourth of the data from the upper three-fourths. Okay, here's the lower quartile. Divides this lower fourth from the upper three-fourths. The middle quartile is kind of the overall medium. It separates the bottom half from the top half. And the upper quartile, or third quartile, divides the lower three-fourths from this upper three-fourths up here. To find them, first you find the middle quartile, which is the median. Then you find the median of the lower half and the median of the upper half. And we'll do an example of that in just one second. Now, the five-number summary consists of the low value, or the minimum, lower quartile, the medium, upper quartile, and then the high value. So we can label these as min, Q1, Q2, Q3, and the maximum. So when you want to find a box plot, first thing you have to do is you find the five-number summary. And the box plot is just a graphical way to display a five-number summary in a rectangular box. So let's look at an example. Here's a box plot comparing the wait times on those two banks, Big Bank and Best Bank. I'm sorry, there's some formatting issues right there. But the five-number summary for both has already been calculated right here and right here. So if you look at the box plot, what they do is they draw, first of all, they have a scale here, and you want to be careful with the scale. This is important. As a matter of fact, it's so important that I'm actually going to highlight the scale to let you know that I want you to be really careful when you draw these to always include the scale. Now, the way that you draw the box plot is, first of all, I'm going to do the one for Best Bank. First of all, you look at the median, which is 7.2, and you draw a vertical line at 7.2. You find that where's in your scale, and you draw a vertical line up here. Then you draw vertical lines for your lower quartile and your upper quartile. So my lower quartile, oh, sorry, I'm not doing Best Bank. I'm doing Big Bank because there's more variation there. Yeah, for Big Bank. So my median here is 7.2. There's my median. Then the lower quartile is 5.6, so I'll draw a vertical line here. And the upper quartile is 8.5, so I will draw a vertical line here. And then you draw the box that kind of connects these things. So that's the box part of your box plot. Then you look at your minimum, your lowest value, 4.1, and your highest value, which is 11. Then you draw a line, a horizontal line, connecting them through your box. So that's your box and whisker plot. These parts on the end are the whiskers of your box. Okay, so just you don't always have to label it like this, but just so you can see, here I have the minimum. Here I have Q1. Here I have Q2, which is also the median. Here's Q3, and here's the maximum. All right. So let me just show you an example from scratch on making a box plot. Let's make a box plot of 2, 4, 4, 5, 8, 10, and 19. So the first thing you want to do is find the median. Remember, median means the very center value. Well, there are 1, 2, 3, 4, 5, 6, 7 data values. It's an odd number. So the median is going to be this very center one right here. So Q2, or the median, is just 5. So once I've done that, I look at this, all the numbers less than my median, and I take the median of those low numbers. So the median of this lower set, 2, 4, and 4, the median is going to be 4. That is my Q1. Q1 is the median of the values less than the overall median. And then you look at the values above your median and take the median of the values above your median. In this case, I get a 10. So that is Q3. And then my maximum is 19, and my minimum is 2. Okay? So that's my 5-number summary. So once you have your 5-number summary, you can go ahead and make your box plot. So let me resize this stuff right here. And we'll make the box plot. So like I was saying, it's extremely important here to make your axis right. Okay. So my lowest is a 2. So I'm going to start at 0. My highest is 19. So I'll end it at 20. And I'll go up by 2s. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and let me just make a slight adjustment here. This is 20. It's a little hard to get this exactly right on a drawing on a tablet, but when you're doing it on your paper, you can be a little bit more precise. 14, 16, and 18. Okay, so I'm going to use a different color. I'll use red. So I'll look at my median, or my Q2, which is 5, and I draw a vertical line right there. Then I'll look at Q1, which is 4, and I draw a vertical line above 4. Look at my Q3, which is 10, and draw a vertical line there, and then I'll draw my box. So again, it's hard to be nice and neat on my iPad, but you can do better on paper. So there's the box part. Now I'll draw the whiskers. My minimum is 2, which is about right here. My maximum is 19, which is about right here. So then you draw your vertical line connecting them. So there is the box plot for those numbers. And you can see here that this data is right skewed because there's a big gap right here. Right? There's this big gap between the box part and the maximum value. So there's an outlier over here. It's 19 is very far away from the rest of your data. So this is right skewed data. Right? So that's that. Now, a more common way to measure variation is with what's called the standard deviation. And it's by far the single most commonly used value to describe variation. We'll hear that talked about a lot. Now, by definition, the standard deviation is equal to the square root of, you look at the sum of the deviations from the mean, so you look at the sum of the deviations from the mean squared, and you divide by the total number of data values minus 1. That's really ugly. Okay, it's really hard to describe. So I'm gonna show you an example following these 5 steps. To calculate the standard deviation, number 1, you compute the mean, then you calculate the deviation from the mean for every data value. And the deviation from the mean is just data minus mean. Once you've done that, you find the squares of all the deviations, add all of those guys up, divide by the total number of data values minus 1, and then take the square root, and that's your standard deviation. This is an important slide. You might want to copy this down somewhere. So let's do an example. Let's find the standard deviation of 2, 3, 5, 7, and 10. So step 1, we want to find the mean and the deviation from the mean for all of the data values. So let's go ahead and do that. So the mean is equal to 2 plus 3 plus 5 plus 7 plus 10 divided by, how how many are there? 1, 2, 3, 4, 5, divided by 5. So this adds up to be, let's see, what is that? What, 27 over 5? And that works out to be about equal to, no, it's exactly equal to, sorry. Let me erase that part. So this is equal to 27 over 5, which is equal to 5.4. So there's the mean. Okay, so I have my mean. So now I need to find the deviation from the mean. So let me shrink everybody down to make some more room. So the deviations from the mean, I'm going to take all of the data values and just subtract the mean. So 2 minus 5.4, 3 minus 5.4, 5 minus 5.4, 7 minus 5.4, and 10 minus 5.4. So let's see, what do we get for all these? This is going to be equal to negative 3.4. This is going to be equal to negative 2.4. This is going to be negative 0.4. This is equal to 1.6, and this is equal to 4.6. So I have all of these deviations from the mean. So what we do now is we're going to square all of these, and then we add all of them up. So let me move them up here. So we look at negative 3.4 squared, negative 2.4 squared, negative 0.4 squared, 1.6 squared, and 4.6 squared. So I'm going to pause this and go ahead and grab my calculator and do all these. So they're all just going to magically appear in 3, 2, 1, and boom, there they are. So negative 3.4 squared is 11.56. Negative 2.4 squared is 5.76. Negative 0.4 squared is 0.16. 1.6 squared is 2.56. 4.6 squared is 21.16. So there's that. Now the next thing we do, to even stretch your ability to view the stuff on the screen by making it really small, is to do the sum of the variations. I'm sorry, sum of the deviations. So we have 11.56 plus 5.76 plus 0.16 plus 2.56 plus 21.16. So these are the numbers we want to add up. And this is going to be equal to 41.2. And I think it's time for a new slide. So we had on the previous slide, we calculated the mean, we calculated the deviations from the mean, the square of all those guys, and then the sum of deviations, the sum of, the square of deviations from the mean. And we got that to be 41.2. So to find the standard deviation, this is equal to the square root of that number we calculated, 41.2, divided by the total number of data values minus 1. Well, there were 5 data values, so that's 5 minus 1. So this equals the square root of 41.2 over 4. So if I put this in my calculator, I'm going to get about 3.2. So 3.2 is the standard deviation of that data set. So that tells you on average how far the datas vary from the mean. So on the next test, there'll be one example with a data set about this big, about 5 values, where you'll calculate the standard deviation by hand like this. There'll be a few homework problems to practice it too. So there's that. Because the standard deviation is such a pain in the butt to calculate by hand, we do have this nice little rule of thumb. It's called the range rule of thumb for for approximating the standard deviation using the range. Now the range is easy to calculate. It's just the biggest value minus the smallest value. So the standard deviation, you can approximate it by looking at the range and dividing by 4. So if you know the range and you want to approximate the standard deviation, you can do it that way. You can also do the other thing. If you know what the standard deviation is, you can approximate the lowest value and the highest value. The lowest value is about the mean minus 2 times the standard deviation. The high value is about the mean plus 2 standard deviations. So for example, studies of the gas mileage of a Prius under a bunch of different driving conditions show that it gets a mean of 45 miles per gallon and a standard deviation of 4 miles per gallon. So we can estimate the minimum and maximum gas mileage you can expect. The lowest value, the minimum gas mileage, is approximately the mean minus 2 times standard deviation. So the mean was 45 minus 2 times 4, because 4 is the standard deviation. That ends up being 45 minus 8, or 37. So 37 is the typical fewest number of miles per gallon you can get driving a Prius. And then the highest value is going to be the mean plus 2 standard deviations. So 45 plus 2 times 4 ends up being 53. So the most miles per gallon you can get for the Prius is about 53. So the range of gas mileage from the Prius is roughly from a minimum of 37 and a maximum of 53. And that's all.